Okay, 7th graders, here's day 2. We have section 1.2 exponents. So our objective today is to be able to represent numbers by using exponents. So one of the things that is nice is just a visual here. What is an exponent? So an exponent is when you have a base raised to an exponent, and the exponent tells us how many times that base is going to be a factor, it's going to be multiplied. So for example, if we have 3 to the second, we have 3 times 3, which in turn would equal 9. If this one, we would have 3 times 3, which is 9, times 3, which is 27. And if we had 3 times 3 times 3, we would have to take 27 times 3. There's one little trick here that I'm going to show you, and you can group them. So I could do 3 times 3 and I get 9, and then 3 times 3 again and I would get 9. Well, what's 9 times 9? That's 81. So this one would equal 81. Okay, so that's what it means to have an exponent. I think you've got a couple vocab words. The only other thing is if you refer to this whole thing, this is called a power. Okay, so that's why this says evaluating powers. So find each value. This means that we're going to have 5 times 5, which is 25. This one, we're going to have 2 times 2 times 2 times 2 times 2 times 2. So I need 6 2s. 1, 2, 3, 4, 5, 6. So sometimes it's nice to group with 2s. You can kind of just keep going. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. Anything to the first power is just itself. So that means I have 125, which is a 25. This one I have 4 times 4 times 4 times 4. 4 times 4 is 16. 4 times 4 is 16. And then if we multiply those together, I think I get 256. Yep. And then this last one here on the side is 7 times 7 times 7. So 7 times 7 is 49 times 7 is 343. So I'll just kind of show you how I did that one. And you could just do the work off to the side in your paper. Okay, so a little fun fact here. Anything to the 0 is always going to be 1. So 6 to the 0 is 1. 10 to the 0 is 1. Negative 2 to the 0 is 1. Make sure that you know anything to the 0. Anything to the 0 exponent is equal to 1. Okay? So the next little thing, they want you to be able to express whole numbers as powers. So they say write each number using an exponent in the given base. So they want to know how would we get to 49 if our base is 7. So basically, if 7 is the base, what is our exponent going to be? So 7 times 7 gives us 49. So our exponent's 2. The next one, our base is 3. What is our exponent going to be to get to 81? Well, let's try it. So 3 times 3 is 9. Times 3 is 27. Times 3 is 81. And we actually did that one up there. So this one, how many 3s do we have? 1, 2, 3, 4. Okay, so this one, base 5. Don't be scared if it's a big number. We just have to know how many times we're going to multiply 5 by itself. So 5 times 5 is 25. Times 5 is 125. 125 times 5 is going to be 625. So your exponent is 1, 2, 3, 4. We had 4 of them. And then our last one here, our base is 2. How many times do we have to multiply to get to 64? Well, actually, we can kind of cheat and go backwards with this one. Otherwise, you just would count how many 2's. You'd have to multiply itself to get up to 64. So that one is 6. Okay, now on to some word problems. Now, sometimes the word problems can be tricky. I really like to try to sketch things out to help me with these. So it says, on Monday, Eric tells 3 people a secret, okay? So on the next day, each of them tells 3 more people. So let's do this. We've got Eric. On Monday, he told 3 people the secret. So these 3 people now know the secret. Then what did they do? Well, they went and they all told more people. They all told 3 people. If this pattern continues, how many people besides Eric will know the secret on Friday? So one thing that I like to do is make a table. So for example, we're going to have Monday, we'll have Tuesday, we'll have Wednesday, and we're going to have to go to Friday, so I might as well make it till Friday. Thursday, Friday. So on Monday, how many people knew? 3 people knew. On Tuesday, though, we had 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 new people knew. So that's what we're going to focus on, then how many new people knew. And then, so what would happen the next day? So if this was tripled, what's going to happen the next day? It's going to triple again. So it'd be 9 times 3, which is 27. 27 times 3, which is going to be that 81. And then 81 times 3, we can do that off to the side here. 81 times 3, and then this is 24. So 243. So this question is a little bit skewed because it says, if this pattern continue, how many people besides Eric will know the secret on Friday? So 243 people is actually how many people would be told the secret. So to come up with how many people would know the secret, we'd have to add all of these together. So we can kind of maybe write this 2 answers. So 243 new people will be told Friday. And then if we want to know how many people besides Eric, so we're going to do 243 plus 81 plus 27 plus 9 plus 3. So 363 people will know the secret on Friday. Okay? Okay, next thing. In a contestant in a game had a starting point of 1 point, starting score of 1 point. She doubled her score every turn for 4 turns. So she started with 1, but she doubled it. So on turn 1, if you double that score, so I'm going to do turn 2, turn 3, and turn 4. So if you double 1 point times 2, you would do here. If you double this, you'd get 4. If you double this, you get 8. If you double this, you get 16. Okay? So it says write her score after 4 turns as a power, then find her score. So we know the score, but what we're going to do is what happened? How did we get to 16? Well, think about that for a second. Let's try a couple different things. Does 2 to the 4th give us that? How many times did it double? So it doubled, let's see, 2 times 2 times 2 times 2. This gives me 4 times 4. Does that give you 16? It does. So this is writing it as a power. This is her score. Okay, the classroom is a square. So I'm going to draw a square with a side length of 13 feet and an area of 169 feet squared. how can you write the area in exponential form? Well, how do you find the area? The area is on a square is side times side. Area is also side squared. So here, my side is 13, so the area equals 13 squared. And if you wanted to put a label on it, you certainly could. Okay, the last one here. It says the cells of the bacteria E. coli can double every 20 minutes. If you begin with a single cell, how many cells are there going to be after 4 hours? So this one's kind of tricky because we've got minutes and hours. So how many 20-minute times are in 1 hour? So 1 hour, it's going to double, well, 20, 40, 60, 3 times. So then in 4 hours, it's going to double 12 times. So I'm going to kind of go back to here because this was the doubling the score one. So it doubled 4 turns, so it was 2 to the 4th. So here, we're going to double it, so the 2 goes down here. And then how many times is it going to double? Well, it's going to double 12 times. And so if we calculate this, so I'm going to use a calculator on this one. So I'm going to do 2 to the 12th, and I get 4,096 cells. So that's how many cells. So there are your notes for section 1, 2.